Hello. Today I am talking about why we are using the Kubernetes. So let's begin. So this is the overview of a Kubernetes. Kubernetes is a portable, extensible, open source platform for managing containerized workload and services that facilitate both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. So, in the traditional era, this is the development where all the hardwares are used and the cost is very high and the portability of the uh, app are very difficult. That time they are called as the softwares. Then the virtualized deployment occur where VMwares come in a picture. So, but still the portability of the application is very difficult and the networking between all the required things which require to make an application working is very difficult. So then it comes the containerized development. In the containerized development, all the things which required like database and the main code, they are all grouped in a single container. But after that, the the scale is increasing. The software world is growing and the hits on the application is increased. To manage all these, we need something which is more efficient for this growing world. So, we talk about the Kubernetes. Containers are a good way to bundle and run your application. But to handle these bundles of containers, you need manpower, which cost you. But we have a scalable process called Kubernetes, which help us to figure out all these things. If the hits on your application on your website is increasing, then it also help us to load balancing. Kubernetes can expose a container using DNS name or using their own IP address. If the traffic to container is high, Kubernetes is able to load balance and distribute the network traffic so that deployment is stable. Storage orchestration. Kubernetes allow you to automatically mount a storage system of your choice such as local storage, public cloud provider, and more. Self-healing. Kubernetes restart the containers that fails. Replace containers, kill containers that don't respond to your user defined health check and doesn't advertise them to client until they are ready to serve. Secret and configuration management. Kubernetes lets you store and manage sensitive information such as password, auth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebundling your container image and without exposing secrets in your stack configuration. What Kubernetes is not. Kubernetes is not a traditional, all-inclusive PaaS platform as a service system. Since Kubernetes operates at the container level rather than at the hardware level, it provides some general applicable features common to PaaS offering such as deployment, scaling, load balancing, and lets users integrate their logging. So, what are the Kubernetes components? When you deploy Kubernetes, you get a cluster. A Kubernetes cluster consists of a set of worker machines called nodes that run containerized application. Every cluster has at least one worker node. The worker nodes host the pod that are component of the application. So this is the overview of a pod. As you can see, this is your container and that thing is pod and it has a IP address. In the second diagram, you can see a volume is attached with a container and still there is a one pod. You can attach as many of your volumes and as many of your containers in a single pod. Volume, containerized app, and IP address. A pod always run on a node. A node is a worker machine in Kubernetes and may either a virtual or physical machine depending on the cluster. Each node is managed by control panel. A node can have multiple ports. I am repeating again. A node can have multiple pods. Each node is managed by control panel. A node can have multiple pods and the Kubernetes control panel automatically handle scheduling the pod across the node in the cluster. This is a node overview. As you can see, node process. This is the Docker. So to communicate each of the process efficiently, we need a service, an abstract way to expose an application running on a set of pod as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar services discovery mechanism. Kubernetes gives pods their own IP address and a single DNS name for a set of pod and can load balance across them. In Kubernetes, a service is a abstraction which defines a logical set of pod and a policy by which to access them. Sometimes this pattern is called a microservices. The set of port targeted by a service is usually determined by a selector. So scale, running multiple instances of your app. Scaling an application. In the previous module, we create a deployment. So scaling overview, this is the diagram. Scaling out a deployment will ensure new pods are created and scheduled to nodes with available resources. Scaling will increase the number of pods to the new desired state. Kubernetes also support auto scaling of pods, but it is outside of the scope of the tutorial. This is written as here. Scaling to zero is also possible. Like we can define how with the increasing of load we can define how many ports can be increased and how many ports, which is the maximum number and minimum number we can define. And Kubernetes also continuously monitor that the number which we defined are maintained. If any of the services fail, it recreate it. Any container stop it, restart it, and if need, it's relog the services. For more videos, please be with us. Thank you.